This is a buffers question taken from the January 2012 Triple E paper. It is question 4D part 2. What we are told is the following. We have a pH of healthy blood at around 7.4. We are told that it has a ratio of hydrogen carbonate to carbonic acid, has a ratio here of 10.5 to 1. We are also told that a patient's blood is measured at a pH of 7.2. We are asked to calculate the hydrogen carbonate to carbonic acid ratio in the patient's blood. That ratio should strike a chord with you in that that ratio appears in Ka. However, we are not actually given a value of Ka. Right, so what is Ka for this particular buffer system? Well, we need the equation for the carbonic acid dissociation, H2CO3. It only dissociates one H+, and you leave behind then the hydrogen carbonate anion, HCO3 1-. If that's the case, therefore Ka is equal to the concentration of H+ times the concentration of HCO3 1- divided by the concentration of carbonic acid. We should also remember that we define pH as equal to the negative logarithm of the hydrogen ion concentration, and therefore the hydrogen ion concentration is equal to 10 to the minus pH. Now, if you remember nothing at all, you should try to remember that these equations are relevant and often given credit. So please write them in your answer, even if you haven't the foggiest how to then go on and answer the rest of the question. Right, if healthy blood has a pH of 7.4 and a hydrogen carbonate to carbonic acid ratio of 10.5 to 1, can we use that information then to calculate Ka? Yes, we can. So let's start off with the first thing, which is the pH of 7.4. If you've got a pH value, then immediately you should calculate the concentration of H+, which, as I said previously, is equal to 10 to the minus pH, and therefore is equal to 10 to the minus 7.40, which is equal to a grand total of 3.98 times 10 to the minus 8 moles per decimeter cubed. This seems about right because you've obviously got a pH of around neutrality, and so therefore you should have roughly a very lowish concentration of hydrogen ions. Don't be put off by the low value. Right, having calculated that, we now need to determine Ka. For that healthy blood, Ka is equal to the concentration of H+ times the concentration of hydrogen carbonate divided by the concentration of carbonic acid. And we need to therefore plug in the values that we are given. We now know the concentration of H+ as 3.98 times 10 to the minus 8 moles per decimeter cubed. We also know this ratio of the carbonic acid, the hydrogen carbonate ion, to carbonic acid. We've got that ratio I've just ticked. So therefore we just put those numbers in, because we know that on the top line its hydrogen carbonate is, the ratio says it's 10.5, and divided by the the carbonic acid concentration, which is 1. And so therefore when we do that simple value, simple substitution in to give you a value of Ka, plug it into your calculator and you should give a value of 4.18 times 10 to the minus 7 moles per decimeter cubed. That is the units. You're not asked for them, but it will be just simply the units of concentration, because two of them cancel out. Right, we now want to move on to the patient's blood. We've told its pH is 7.2, so again, given a pH value, you should immediately calculate the hydrogen ion concentration. So again, the hydrogen ion concentration is equal to 10 to the minus pH, which is equal to 10 to the minus 7.20, which comes to a grand total of 6.31 times 10 to the minus 8. Again, that is a very similar value to the one you got previously for the healthy blood, and therefore you shouldn't be at all surprised that you get a very similar value. Now then, you need to then use the value of Ka that you calculated in the healthy blood, because as I said at the beginning, both Kas will be exactly the same. So Ka is equal to the concentration of H plus times the concentration of hydrogen carbonate anion, all divided by the concentration of the carbonic acid. This can be rearranged such that you end up with just the ratio of hydrogen carbonate to carbonic acid, which is exactly what you want, simply by saying that Ka divided by the concentration of H plus is equal to the ratio that you are wanting to calculate, hydrogen carbonate over carbonic acid. So let's put the numbers in. Well, from previously that we had a value of Ka at 4.18 times 10 to the minus 7, and we then divide it by the concentration of H plus, which again we have just calculated at 6.31 times 10 to the minus 8. That will give you a grand total of 6.6 divided by 1, or 6.6 to 1 as the ratio, which is what you're asked to calculate. Where will the mark points come from? Well, if you wrote absolutely nothing down other than that final ratio of 6.6 to 1, you would have got your 5 marks immediately for this part of the question. You get mark points for simply being able to do this rearrangement, so being able to put the two numbers over each other, that would have given you another just 1 mark. For determining the value of the concentration of the patient's blood, in other words, this 6.38 times 10 to the minus 8, that would have given you another mark. You would have got a mark for determining the value of Ka, this 4.18 times 10 to the minus 7. That would have given you another mark. And lastly, you would have got a mark for being able to correctly determine the concentration of H plus in healthy blood, the 7.40 value, which you should have calculated, as I said earlier, at 3.98 times 10 to the minus 8. This is a very common sort of question these days. They do seem to want more working out the ratio rather than individual concentrations.